Hi, hello there. So today we're going to have a look at modular arithmetic. Or rather an element of it. Okay, now we've come across this before. This is all about absolute values. However, we're going to look at it in terms of how we can graph and how we can solve. So I'm going to do a few examples of this. I'll do a very simple example. So first of all, I'm going to solve this one. Okay, so how do I solve this one? Well, it's very simple. What you do is you split it up into two different sums and you solve x plus 3 and you solve x plus 3 equal to the negative version of it. So the answer to this one is going to be negative 2. The answer to this one is going to be negative 4. And there's your two possible answers. And they might give you some information about which one to ignore. Okay? Now, next I'm going to show you what happens when you have on both sides. Now, as you can see, with this type of one, because both of them have an absolute value on them, you don't know which one to make minus and which one to make plus. So when you get this scenario, uniquely in this scenario, the easiest thing to do is square both of them. And that will hopefully solve the problem. So squaring this, you get x squared minus 10x plus 25 equal to x squared plus 2x plus 1. Move everything to one side, the usual. That's going to leave you with x squared minus 10x minus 2x, and then move the 25 the other way, equal to minus 25 plus 1. So let's have a look at this. X squared minus x squared is gone. That's minus 12x is equal to minus 24. X is 2. There's only one possible answer for this one. Okay? So that's a little bit different, that one. Now, let's see what happens when you draw these things. Okay? So drawing these things is a lot more fun. So I'm going to draw this one for you. I'm going to draw 2x minus 5. Okay, so how would I draw this? Well, what I do is I imagine that these lines don't exist, and I would have a sum like this: y is equal to 2x minus 5. And I'd say to myself, well, how would I draw y is equal to 2x minus 5? Well, what I do is I would let x equal to 0 and solve for y, and then let y equal to 0 and solve for x. And that would give me an x and y intercept to allow me to draw the line. So I'm going to do that. If I let x equal to 0, y is equal to minus 5. So one of the points of this line would be 0 and minus 5. And then I'm going to let y equal to 0, and that would give me x is equal to 5 over 2. So I'd have a second point, 5 over 2 and 0. So let's just draw these very quickly. So I'm not going to be, this is a sketch, so I'm not going to be doing this to any type of scale. Usually in an exam, they wouldn't give you the scale. So quite roughly speaking, let's say 2.5 and 0 is there. And let's say minus 5 is down there, just roughly speaking. So this is how it works. Remember, we're drawing something that has an absolute value, so it only has a positive component. So if I try and draw this whole line, it's wrong. I only want this bit of it. Okay? However, there is another possibility. If I make this equal to another number, I would have to get the plus and minus version, just like I did. So I need to reflect this back into the x-axis. So how do I know how far to reflect it? Well, it's going to be a symmetrical number. So whatever down there will be the same up there. So if that's minus 5, that's plus 5. So that's how I'd reflect it. And that red is that shape. Okay, and as you can see, it does not go below the y-axis. So using this, let's say I want to find where 2x minus 5 was less than, just to give a nice little example, 3. So I've drawn it. Now let's draw 3. Okay? Well, there's 5, so let's say 3 is there. Put them in a different color. So there's 3. So I want to know where this red line is less than 3. Well, it's less than 3 anywhere between these 2 points. So I need to figure out what these 2 points are, and then between it, all in this area, between there, that's where it's going to be less than. Because once you go above that point there, red starts getting bigger than this line. And I want it where it's below, less than that line. So how am I going to do this? Well, I can see I could read it off if I had this to scale. Okay, I could easily read this off if this was to scale. I don't have it to scale, so I can solve it algebraically. I can just go 2x minus 5 less than 3, or 2x minus 5 less than minus 3, and solve them both separately. So that's 2x is equal to 8, x is less than 4. And then that's 2x is equal to 2, x is less than 1. Now, that can't be true, in that if this is 4, then this must be the upper value, so that's 4 there. So it's definitely less than 4. In here is less than 4, going this way. The problem is less than 1 would be going out this way, and that's not true. So one of them has to be wrong if I want to show where it's less than. Okay? So one of them has to be flipped. So really what I'm looking for to describe this area is less than 4, but actually greater than 1. That's the area I'm looking for in there. And that's how to do an inequality like this. Okay? So I'm going to do a more complicated one just to show you it's the same thing. But remember, these are all going to be exactly the same. So it really is just a case of being very, very, very careful with them. Okay? So let's have a look. Let's pick a little bit of a tougher one. Let's go 1 over 1 plus 2x absolute value equal to 1. So let's see what this looks like. Let's solve this one. So while this looks really unusual, again, we can just use the fact that 1 over 1 plus 2x would be equal to 1, or 1 over 1 plus 2x could be equal to minus 1. So let's solve both of these separately and see what happens. Multiply both sides by the denominator. So you're going to get 1 plus 2x equal to 1. X is equal to 0. That's the only way that works. And then you're going to get minus 1 times 1 plus 2x equal to 1. That's minus 1 minus 2x is equal to 1. Minus 2x is equal to minus 2. Sorry, is equal to 2. X is equal to minus 1. So there's your two possible solutions that would make this work. Okay? Now, if that was a less than or equal to, you could then decide, well, you know, I could sketch it if I wanted to, or I could try and solve it. Okay? So that's how you do your modulars.